Hello. So, this is a revision lecture for representation of signals in the form of step and ramp. So, I'll write it down here. I hope it is visible. Representation of signals and ramp. All right. So the first example that we were left with in the last lecture was this. Like it was similar to this. I'll take different pen. Is -2, is 3, this is 7, this is 3. This is the time axis, and we'll just call this function f of t. Okay, so in order to represent it as a step in the form of step and ramp, first we can see अभी इस केस में तो हमें like we can't see any slope or any sort of a uniform slope. So as we can see at this point at -2 and at this point at 3 and at 0, there is a sudden increase or decrease in the amplitude of the signal. So according to our technique, we can write there is sudden change at t equal to -2, 0 and 3, correct? So then just we'll look key what is the change in amplitude at each of these points. So at t equal to -2, the signal goes from the value 0 to amplitude 3, correct? So here we will write the final value is 3, the initial value is 0, so that is 3 minus 0, that is 3. Then at t equal to 0, the signal goes from value of 3 to value of 7, so there is a jump of 4. So 7 minus 3, that is 4. So we can write at t equal to 0, there is a jump of 4. And similarly at t equal to 3, the signal falls from 7 to 0. So there is a decrease of 7. So we can write 0 minus 7, that is -7. So at t equal to -2, what is t equal to -2? T equal to -2 means t plus 2 equal to 0. So we will write u of t plus 2. Then at 0, what is at 0? U of t. And what is at 3? That is t equal to 3, that is t minus 3 equal to 0. So that is u of t minus 3. And similarly we'll just write what is the jump. So at t equal to -2, the jump is +3. So we'll write here +3. Then at t equal to 0, the jump is +4. So we'll write here +4. And at t equal to 3, the jump is -7. The change is -7. So we can write here -7. So this is f of t in terms of step signals. Alright. Now we'll just look at another signal which we can represent using step. Alright. Is this a good? Okay, let it be. We'll take another paper. So we'll take another example. I hope my lines are straight. This is, for example, -1 to 2, and then the signal goes from here to here. Let's say this is -4 to 2. This is the time axis, and we'll call this signal, for example, f1 of t. Okay, so similar to what we did in the last example. Where is the jump? Which are the which are the points where we can see the jump? We can see the jump at t equal to -1. Then we can see the jump at t equal to 0, and we can see the jump at t equal to 2. So it is t equal to -1, 0, 2. Then what are the jumps? At t equal to -1, it jumps from 0 to 2. So the jump is 2 minus 0, that is 2. At 0, it jumps from the amplitude 2 to amplitude -4. So the jump is negative. So that will be -4 minus 2. -4 minus 2, that is -6. And at t equal to 2, the jump goes from -4 to 0 again. So the jump is from -4 to 0, that is 0 minus -4, that is +4. So we can directly write the equation like this: f1 of t equal to, at -1 it will be u of t plus 1, and the jump is of 2 plus 2. At 0 it will be u of t, and the jump is of -6. And at t equal to 2, that is u of t minus 2, the jump is of +4. So we have written f1 of t in terms of step signals. As you can see, we just checked where the signal is suddenly changing its amplitude, and we represented it in the form of step signals. Okay, now we'll take an example for ramp. So hopefully it is visible here. I'm hoping it is. Wait a second. So we'll take another example for ramp. Is it visible? It is. So this signal goes from -2 to 2, and this amplitude is 4. All right, this is the time axis. Let's just call this signal f2 of t. So in case of ramp, we have to focus on the change in slope. All right, we have to focus on the change in slope. So now here, what is the slope here? Here, what is the slope? It is a horizontal line, so the slope will be 0. Here and here, the slope will be 0. Then what will be the slope at this point? Like, what will the slope when it is rising like this? What will be the slope? The slope will be, we can write it as change in amplitude upon the difference in time, right? So the amplitude, it changes from 0 to 4. The amplitude, it changes from 0 to 4 in this much, that is 2 units. So that is 4 by 2, that is 2. So this slope is 2. Similarly, this slope changes from 4 to 0 in 2 units. So its slope is -2, and this is again 0. So from this only we can see that there are 3 points in which the slope suddenly changes, right? So just like step signal, what we can do is slope changes at minus 2, here minus 2, 0 and plus 2 or 2 here, correct? And at minus 2, now what is the change in slope? So at minus 2, the slope changes from 0 to 2, that is the change is 2 minus 0, that is 2. Then at t equal to 0, the slope changes from 2 here, 2 to minus 2. So the change is minus 2 minus this 2. So it is minus 4 as it changes from 2 to minus 2, correct? And at t equal to 2, the change is again minus 2 to 0, that is 0 minus minus 2, that is plus 2, correct? And so just like that we can write the function of this signal as f2 of t as at this point. So just like that, at minus 2, so t equal to minus 2, that means t plus 2 equal to 0. So at r of t plus 2, the slope changes by plus 2, so it is 2. Then at t equal to 0, the slope changes by minus 4, so it is minus 4. And at t equal to plus 2, that is here, the slope changes from minus 2 to 0, that is changes by plus 2, so it will be plus 2 r of t minus 2, because it is t equal to 2, so t minus 2 equal to 0. Excuse me. Yes, so hopefully it is visible in the video. Yeah, it is. So we have written the equation of this signal, this one, correct? Now we'll take an example in which there is both. All right, otherwise I'll show an example in which it can be a bit confusing. All right, it can be a bit confusing. So for example, is it visible? Yes, it is visible. This is minus 2, this is minus 1, 0, 1 and 2, and the amplitude is, let's say, 10. All right, it's 10. Okay, so now in this example you might say ki there is a step as well as 2 ramps, but if you observe carefully, is there any sudden change in amplitude? Is there any sudden change in amplitude here? No, right? There is no sudden change in amplitude. Okay, so we can say that there is no step in this. There is no sudden change in amplitude. That means there is no step in this. There is no unit step in this. All right. So then for unit ramp, there are how many points at which the slope is changing suddenly? How many points? We can see the slope changing at t equal to minus 2. We can see the slope changing at t equal to minus 1. We can see the slope changing at t equal to 1 and t equal to 2, correct? So similarly we'll do how much the slope is changing by. So here the slope is 0, here the slope is 0 as it is horizontal. Here also the slope is 0 because it is also horizontal, right? Now here, so what is the change in amplitude between this time period of 1? It is minus 2 to minus 1, so the time period is 1. The change in amplitude is 0 to 10. 0 to 10. The change in amplitude, this is 0 to 10. So the slope will be 10 by 1, that is 10. And similarly this will be minus 10. Correct? So the slope is 0, 10, 0, minus 10, 0. So it is changing at which points? Minus 2, minus 1, 1 and 2. Now at -2, the slope changes from 0 to 10. 0 to 10, that is 10 minus 0, that is plus 10. Correct. Now at -1, the slope changes from 10 to 0. It changes from 10 to 0. That means final minus initial, that is 0 minus 10, that is minus 10. Right? Now here it is 0. At t equal to 1, the slope changes from 0 to minus 10. It changes from 0 to minus 10, so it reduces. Right? So it reduces by minus 10 minus 0, that is minus 10. And similarly at t equal to 2, it changes from minus 10 to 0. That means the slope increases. Minus 10 to 0, that is 0 minus minus 10, that is plus 10. And I'll just write, okay, let's say this is f3 of t, for example. This is f3 of t. So f3 of t is equal to, now I'll write the equation directly. This is t plus 2. Okay, I'll directly write the equation. Minus 10 t plus 1 minus 10 r t minus 1 plus 10 r t minus 2. Right? This is the first term, second term, third term, fourth term, corresponding to these 4 points. Yes. Now we'll take one. Okay, wait, let me get a paper, or I'll just continue it here. Should I? It's good enough, I guess. So here we'll take a mix example. Maybe you might not. Okay, I'll just draw it. And let's say this amplitude is 10. Alright, this is the time axis. This is f4 of t. F4 of t, is it visible in the video? Yeah. So f4 of t. Now in the first look, what will you observe? You can see there is one sudden change in amplitude, so there should be at least one step signal, correct? And you can see one ramp signal, right? But if you observe carefully, what is ramp? Ramp is sudden change in slope. Ramp is, what is ramp? Sudden change in, okay, change in slope. And step is sudden change in amplitude. Correct. So how many, okay, let's just write the slope. The slope here is 0. Then here it becomes, this is 2 units, and the amplitude changes by 10. So the slope is 10 by 2, that is 5. And here the slope is again 0. Right? So the slope changes from 0 to 5. And then again 0. So there are 2 points at which the slope is changing. There are 2 points. 2 ramps. Right? We'll observe that in the equation. And how many points are of step? Here there is sudden change in amplitude from 10 to 0. So there is one step signal. So we'll write the equation for this signal, f4 of t. So at t equal to 1, there is a ramp which changes from 0 to 5. So we can write plus 5 r of t minus 1. Correct? Plus 5 r of t minus 1, because at t equal to 1, the slope is changing from 0 to 5, that is 5 minus 0 is plus 5. So plus 5 r of t minus 1. Then at t equal to 3, the slope is changing from 5 to 0. It is changing from 5 to 0. So we'll write 0 minus 5, that is minus 5 r of t minus 3. Minus 5 r of t minus 3. Correct. And now we'll also write about the step. The amplitude changes from plus 10. Amplitude changes from plus 10 to 0. Plus 10 to 0 here. So that is 0 minus 10, that is minus 10 u of t minus 3, because it is at t equal to 3, so it becomes t minus 3. Correct. This becomes the equation for this signal. Correct. Yes. Now we'll take another example, just for a like brief revision of whatever we have learned. All right, let's say it is like, I will draw it neatly this time, ekdam proper. 1 2, it goes from, let's say, here to here, then there is a jump, and I won't say it, I'll just draw it, and then it comes down. So this is 15, this is 15. Okay, this is at minus 1. Okay, so let's just apply whatever knowledge we have learned. This is the time axis. Let's call this, what is it, f5 of t. Okay, so let's just apply our knowledge. Okay, so we can observe only one sudden change of amplitude here we can observe one sudden change in amplitude at t equal to minus 1. So, and what is the change in amplitude? The change in amplitude is 10 to 15, that is 15 minus 10, 15 minus 10, that is plus 5, 15 minus 10, that is plus 5. So let's write it down first of all, so that we can take the ramps together. This is plus 5 u of t, it happens at t equal to minus 1, that is u of t plus 1. Now we'll look at sudden change in slope. So the slope changes at how many points? Here the slope is 0, here the slope is 0, here the slope is 0, because it is horizontal. What is the slope here? The slope here is, this is 1 unit, and the change in amplitude is 15 to 0, that is 15, and as it is coming down, it will be minus 15 by 1, that is minus 15, right? And here the slope is in 1 unit of time, the slope is it changes from 0 to 10, so it will be 10 by 1, sorry, that is 10, the slope is 10. So we'll write here, let's write now, at t equal to minus 2, the slope changes from 0 to 10, that is 10 minus 0 plus 10, r of t plus 2, because it happens at t minus 2, at t equal to minus 1. Now at t equal to minus 1, the slope changes from 10 to 0, it changes from 10 to 0, that is 0 minus 10, that is minus 10, at r of t plus 1, I hope it is in clear. It is clear in the video. Then the slope again changes at t equal to 1, t equal to 1, and it changes from 0, horizontal 0, to minus 15. It changes from 0 to minus 15. So that is minus 15 minus 0, that is minus 15 r of t minus 1 because it is at t equal to 1. And again it changes finally at t equal to 2. At t equal to 2 it goes from minus 15 to 0, minus 15 to 0, that is 0 minus minus 15, that is plus 15. So it is plus 15 r of t minus 2. Done. We have applied whatever we have learned in this lecture and solved 5 examples and represented all the signals in the form of ramp and step. Yes. Good night. Good night.